thing we're going to look at is recognizing different sequences. So in each of the sequences below, we're going to look at what's happening in each of them. In the first one, it's multiplying by 4. So 4 by 4 is 16, 16 by 4 is 64, 64 multiplied by 4 is 256. So if you're asked to find the next term, you'd multiply it by 4, or the previous term by 4, and that's called an exponential sequence. So when it's been multiplied, it's called exponential. In the second one, it's going up. The common difference is 2, so it's going up in 2 each time, and that's called a linear or an arithmetic sequence. The third one, and the linear arithmetic could be going down in 2s or up by 3s or whatever it is, once the common difference is the same. In this one, there's no actual pattern happening. There's no mathematical pattern. But what's happening is every 4 terms, it's repeating itself. So 4791, 4791, etc. Again, sometimes there may not be a mathematical rule, and just see if there is, and if there isn't, then that's called a repeating pattern or a repeating sequence. In the fourth one then, which it's not multiplied, the common difference isn't the same as plus 6, plus 9, plus 12. So the first difference isn't the same, but what is the same is the second difference, which is the difference between the first and second difference. So you're adding on 3 to the previous term every 9. So if you were to ask to find the next term, you'd be adding on 15 to 49, which will give you 44. So the second difference is the same, and that makes it a quadratic sequence. Next thing we'll look at individually is repeating sequences. So these could be in shapes or in numbers. The shape one is probably more obvious as repeating because obviously there's no numbers. So you can see here, every 3 shapes, this sequence repeats itself. So to get the 39th shape, you divide 39 by 3, and because it goes in evenly, it's the last sequence in the shape. So it's going to be the square. So it's going to, if it divides in evenly, it's the last sequence. So therefore it's a square, yeah. In the next one, again, same kind of idea, whether it's a shape or a number, it's repeating. And this one is repeating every 4 terms. So what you do is you divide 82, and this is kind of the best way to do this is probably, if it doesn't divide in evenly, do it the old-fashioned way, where you have remainders. So that goes in 20, remainder 2, and the remainder means it's the second term in the sequence. So remainder 1 will give you 7, remainder 2 will give you 4, and so on and so forth. If there's no remainder, last term 5, remainder 3 minus 1. So because it's the second term, remainder 2, it's the second term of the sequence, so it's equal to 4. So the 82nd number, or the 82nd number in that pattern, is equal to 4. Here we are looking at arithmetic or linear sequences. And we're asked, first of all, to explain why it's linear. And it's linear because the common difference is a constant or is the same. In this case, the common difference is constantly going on in minus 7s. So you subtract 7 from the previous term to get the next term. So the next term will be minus 15 minus 7, which will be minus 22, minus 7 minus 29, and minus 7 will be minus 36. To find the nth term, or the general term of an arithmetic sequence, we use the formula on page 22 in the log tables, where Tn is equal to a plus n minus 1 by d. And to do that, we're told in the log table that a is your first term, so the first term here is 4, and d is your common difference. The common difference in this linear sequence, because it's linear, it's going up in 3s, and you can see it there. So submit your formula. We're looking for the t of n, so we leave n as n. So 4 plus n minus 1 by 3, multiplying by the 3, so 4 plus 3 by n is 3n, 3 by minus 1 is minus 3, and in this tidiest form that becomes 3n plus 1. So that's the nth term of that sequence. And the next part of this question, we're asked to find the t of 17, which is the 17th term. So you sub 17 in for n into your nth term, so 3 by 17 plus 1, which gives you 52. So 52 is the 17th term. And then the other way they could ask this one is, if they could ask you which term is equal to a certain number, and this is where we're looking for n. So the term number is n. So instead of subbing in for n, we leave 3n plus 1 equal to 109. So using algebra, 3n is equal to 109 minus 1, which is 108. So n is going to be equal to 108 divided by 3, which is 36, sorry. So n is equal to 36. So that means the 36th term is 109. So quadratic sequence, explain why the following is a quadratic sequence and then find the next three terms. So it's a quadratic sequence when the second difference is the same or a constant. So you can see here it's going up 3, it's going up 7, this is going up 9. Sorry, this is going up 7, it's going up 11, plus 11 and plus 15. That's our first difference. And your second difference is going up in 4s. So to get the next term, what you're adding on is you're adding another 4 to 15, so you're adding on 19. To get the next term after that, adding on another 4, which is adding on 23, and you're adding on 27 to get the next term after that. So to find the next three terms, the next one's going to be 49, because you're adding on 19, adding on 59. So next term is 59. When you add on 19 to that, add on 23 to get the next term, which is 82. And you add on 27 to get the next term, which is 109. Because you're constantly adding on 4 from the previous term, because 4 is your second difference. To find the nth term of a quadratic sequence, we need to learn off this formula. So the t of n of a quadratic sequence is not in the log tables. So it's an squared plus bn plus c, where 2a is equal to your second difference. And you just have to learn that off. So we get a first, and to do that we need to find our first and second difference. So you can see here our first difference is plus 6 plus 10 plus 14. Your second difference is plus 4. So in this case, 2a is equal to your second difference, in this case is 4, so a is equal to 2. So to find the general term of a quadratic, we need to find a, b, and c. And we know that 8 is the first term, t1, and t2 is 14. We don't need to use these terms really. So knowing that t1 is equal to 8, using your formula here, you sub 1 in for n, so you already know a, so 2 by 1 squared, so 1 is the first term, n is the nth term, so sub 1 in for n, plus b by 1 plus c, and that's equal to 8. When you tidy it up, you get a simultaneous equation. It looks like b plus c is equal to, this becomes 1 squared is 1, 1 by 2 is 2, 8 minus 2 is 6. That's your first simultaneous equation. To get your next one, we're going to use the second term. So you know the second term is equal to 14. So this time, again, we know a is 2, so it's 2. This time we're putting 2 instead of n as well. 2 squared plus b by 2 plus c. And this time it's equal to 14. That becomes 2b plus c is equal to 2 2s are 4, 4 2s are 8. 14 minus 8 is 6. So 2b plus c is equal to 6. And now using them two simultaneous equations, b plus, we get our values for b and c. b plus c is equal to 6, and 2b plus c is also equal to 6. I'm going to multiply the top line cross by minus 1. Again, there's a couple of ways you can do that. So what happens is these change signs, and you end up with b is equal to minus 6 plus 6 is 0, so b is 0. And subbing in your value into one of the equations, we'll take b plus c is equal to 6, so 0 plus c is equal to 6, so c is equal to 6. Now you have your a, b, and c values, so what you're asked to find is the general term. So tn is equal to a is 2n squared plus 0n, and again I don't need to put that in because b is just 0, so 0n is 0, so 2n squared plus 6. And I'm running out of space here. To find the 42nd term, the t42, you sub 42 instead of n, so it's 2 by 42 squared plus 6, and put that in your calculator. That will give you the term, the 46 terms there. Last one we'll look at is exponential sequences. It's exponential this time because to get the next term, you're multiplying by term before. And how you know that is 9 divided by 3 is 3, 27 divided by 9 is 3. So you're multiplying by 3 to get the next terms. So to get the next 3 terms of that sequence, you just multiply your previous answer by 3. So 27 multiplied by 3 is 81. By 3 is 243. And you multiply that by 3 again, you get 729. If you were asked to find the nth term, there's no rule as such for these yet at junior cert, but to get the next term, it would just be 3 to the power of n. So 3 to the power of n will get the next term, because whatever the power is, you get the next term. 3 to the power 1 is 3, 3 to the power 2 is 9, and so on and so forth.